And now we're moving on to the bushing. Now, I found an issue. If you were to, the bushing that they show you, or that the person in the write-up actually made, was this one with the extended shank right here before the threads. But also included in those is this one, which is more like the original Southbend version, which is the screw ends right at the collar, which is what I'm going to make. But the measurement callouts for this, 632 thousandths, okay, and then you have to bore your steps for your 1/2 inch collar here, your ring where your bearings are going to ride, and then the other ring that's going to sandwich everything together. So from here to here, your depth is 692 thousandths, which means that you'll actually be into where your threads are going to be. Now your threads are only 9/16 of an inch. So that's only 563 thousandths from here to here, plus your thread relief to your thread depth, which is probably about what, 32 thousandths or so. I'll have to figure that out mathematically. But basically, when you try to cut your thread relief, you're gonna part your piece off. That's what's gonna end up happening. So what I had to do, or what I figured on doing, is I'm gonna add 100 thousandths to this outside dimension to bump this piece out further. Now, after doing that, I realized that this piece is not, the screw that we made is not going to be quite long enough to be able to grab the brass screw. So I actually had to end up making another one, which is this one. Which, the only difference here is I added 100 thousandths to this dimension here, keeping the thread depth the same. So in other words, it'll bounce it out this way by 100 thousandths of an inch. And I also, instead of having this collar that big, it's just enough to be able to grab those the bearings and washers. So that way there, I only have to take a couple of thousandths on this dimension here and make sure I have enough meat to be able to withstand the pressure of my threading, so either I don't snap this off or I don't part it off when I do this. So basically this 3/8 diameter is going to be all the way up to here. And you know, my mistake for not looking ahead, but it's only a stupid mistake if you make it twice. So I got to cut this piece 1 inch, 328 thousandths here. I got to cut my blank, which I'm going to go do on the bandsaw now. Alright, we're over on the bandsaw. I just want to show you something real quick. The only one issue I was having with, well, it's not really an issue, but one thing I didn't like about this bandsaw is that there's no way of locating the blade down by your stock to be able to mark off your length. In other words, there's no positive location in here. There's no mark, and these the vice jaws here don't come out to the blade length. So you really have no other way of gauging where your blade cuts until you lower it and rest it on your stock. I didn't like doing that just because of the fact that this is not the original blade. This is I believe this is actually a Lennox bimetal variable pitch blade. They're relatively expensive. I'm pretty sure I paid like 30 and change for this. But I don't want to sit it on the stock and end up either bending a tooth or breaking a tooth. So what I found is one of these here, which is just a laser sight, and the instructions, let me see if I still have the box that it came in, and you can see it mounted to just a skill saw there. So I just it's up there by magnets right now. I haven't figured out exactly where I want to mount it on this permanently yet, but basically I have it lined up to where my blade cuts, and let me shut up the lights. Now I have a nice laser guide to be able to measure right off that stock where I need. The end of this laser is where my blade comes, so I can measure wherever I need to now and how much length. Makes it a lot easier. So let me cut this off, and I'm going to face one end off and we'll get it up in the lathe. Alright, I got my part cut. I'm a little bit bigger than I need. My jaws here are 1.5 inches, and my part is going to be smaller than that, so I can't just put it in there and be able to work with it and cut it down to the dimensions I need, so I do have to bump it out a little bit. Now I know my saw cut is really crooked. That's because of I lost my alignment on it when I broke the adjustment hand wheel, but and I just really haven't got back to getting around to taking it apart and fixing that, which I'm gonna have to eventually. But to locate a part in a chuck that is not all the way against something solid, let it float in the jaws and then gently clamp it down until you hit it right about there, so you can still wiggle it. As you wiggle it around, tighten it, you'll feel it center itself on those jaws. If you have a decent chuck, your jaws aren't bell mouth, you'll get it. Now this is going to be wobbling like crazy, but this top right here, you should see almost little to no run out on that. You throw an indicator on there and I see actually how much it is. I just threw an indicator on there real quick, and without adjusting anything, we're within 2 thousandths or so, 2.25, maybe a little bit less. That's perfectly acceptable for what we're doing. We're just making a bushing, and that outside is going to be concentric with everything else because we're going to be cutting it down anyway, so I don't have to go through the process of adjusting this chuck in. But you can see how wiggling it around like that, you can get yourself pretty good on center, as long as you get a decent chuck to do it. Okay, now we're at about 1 inch 428 thousandths, and we have to go down to 1 inch 328 thousandths, so I gotta take 100 thousandths off of this. As you can see, we're below my chuck, so I can't push this all the way back to the flat of the chuck and use that to align it. And I want to be able to I mean, I can, like I said, I can wiggle this around and get it pretty damn straight, but I want a positive stop because I want to be able to take this in and out and measure it if I need to, and also when we drill the middle out, and bore the middle out, I don't want the pressure of the drill and the drilling operation to slowly push this back into the chuck. So what I have here is just a ring that's 1 inch long here by the diameter of my part. I cut it off of this piece of stock I had laying around. Now you're gonna get tolerances in your metal stock. Like this was 2 thousandths over 2 inches, and this is actually about 3 thousandths under 2 inches. So I had to take 5 thousandths off of this to get it down to be able to use the jaws to clamp it. It's actually a 1/2 thousandth under that, just so that the jaws will clamp onto my part, just like so. So if I push that in, tighten it down, now I have enough sticking out here so that I can machine this down to the 1 3/4 inch diameter that we need, and I also have a way of relocating it into the exact same spot every time I need to take this out, or if I do need to take that out. Now I need an accurate way of measuring carriage travel in to be able to face this. Now you can use a compound to feed in and go off the angle and do your trig and all that other stuff, but that's a kind of a pain in the ass. So this is the one good thing here about having these metal plates. So all I have is a magnetic base with the 2-inch travel indicator. I can clamp right onto that and move that up a little bit. Let that ride right on that. So what I'll do, let me come in and just touch my tool off here. Hold on a second. Not as square as I would like. Okay, we just touched there. I'm going to lock my carriage down. Actually, move this indicator back so we get a little bit more travel in it. There we go. Now, what I'll do, I'll just set my 0. And remember where this ticker is here as we move it, because this is 2-inch travel indicator, so that's going to be, as you can see, when these go around, there's one whole revolution there to 600 thousandths, another whole revolution to 700 thousandths. So right there, is my 0. We'll unlock my carriage, and we have to take 100 thousandths off, so we'll do 30 at a time and then the final 10. So there's 30. Those chips are just flying everywhere because I'm doing a very, very fast feed. If I slow down, they start to curl up. I'm not worried about surface finish right at this moment. I just want to get it down to length. Get to this, finish doing this, and I'll show you the last 10. Alright, we're ready for that last 10 thousandths. Lock my carriage down. Now this is all hand fed. Going very slow as I want a nice surface finish. Very round nose tool bit in here. it is. Go over to the bench. Okay, so just to double check up part, we want 1 inch 328 thousandths. Got 1 inch 326 and a half, 27. So within about 2 thousandths or so, it's perfectly fine. It's not a super critical dimension there. Where our more critical dimensions are going to be this length for the thread. And that's it. So I'm going to put this back in the chuck, and then I'm going to take down as far as I can. This is 2-inch stock. I need to take it down to 1 3/4 inches because that's the size of my dial that I'm going to be using. So I have to take this and I put it in the chuck and go as close to the jaws as I can, and then when we turn it around to do the other side, we'll take it back and meet it. Alright, as you can see with different tool angles, how close I was actually able to get down to the chuck jaws. I used my round nose for my finishing cut, and to take all my heavier cuts I used my roughing tool, which pretty much looks like this. And with a this is a sharp point, there's almost no radius on the end there. The clearance between here and here is a little over 60 degrees, so you can get in like this into a corner and you can face out too. It's like so, but and it gives you clearance on the end here, just like that. And then the rake on the top, 10 degrees, and the front will be 10 degrees. And then my regular round nose tool bit is about 15 degrees here, very round radius here, .10 right here, and 10-degree back rake. That's to decrease tool pressure, to bring this cutting edge right up to it. And then about a 15-degree side rake. Alright, so now let me just measure this real quick. My nice new Starrett micrometer. About 753, maybe slightly less on the dial. And I don't know if I can get that to focus with the light. Come on, camera. I don't know why that's being temperamental now. It worked fine a second ago. There we go. 752 and a half, 52 3/4. Pretty. Not bad. I have no visible or no feelable step between the two diameters. Now I'm gonna center drill this side, and I'm gonna center drill here, and I have to bring this diameter out to 3/8. I'm gonna center drill this. I'm gonna drill 1/4 inch pilot through that way there, and then I'm gonna go up to one size below 3/8, just 25/64. That way there we have enough meat to be able to ream this. And you want to go I don't want to go plowing through with the larger drill bit, because if for any reason if the drill bit's not ground 100% correct, if I have too much tool pressure, if I'm trying to force it in it's going to want to walk. Even though everything is on center, and the actual pressure of the drill bit is going to skew that hole off center. So take your time, go with the smaller drill bit first, and then step up to the larger one. Now we have a 1/4 inch hole piloted in there. This is 23 64 drills, 1 64th below the 3/8 finish size that we're going to use, but we're going to ream to that size, and I'll show you how we're going to do that. Heavier drill, you want a nice heavy appropriate cutting oil. This just happens to be regular sulfur based oil, just because we're going right through cold rolled steel. And you see how easy and nice that cuts now that we have that pilot hole fit. If I were to try to force this thing through this steel to begin with at this size, it'd be a lot harder, and I'd have a hell of a lot more chance of burning out the bit. Not to say that you can't do it, it's just not really something I would recommend. Like I said, I'm not in production. This is for me. I have all the time in the world to do it, so might as well take my time and make sure I don't screw it up. Well, there we go. Alright, now we're going to ream that to 3/8 of an inch, and I want to show you some differences between reamers just before we get started. Alright, here's just a quick assortment of reamers, just different types. Just want to show real quick. This is a taper shank reamer. Obviously, it's held into a Morse taper. This happens to be Morse taper 3. Usually find you can get at almost any size in a taper shank, but usually your larger ones will come in this, are available in this configuration. This one happens to be 499.5 thousandths. This actually, you know what? This is a tapered reamer too. It's tapered only 0.2 of a thousandth, I think. I don't know if we can read that. I don't know if I'm reading that wrong, but usually 0.4993, 0.4995. 7? I can't really make that out. Anyway, that looks like it to be a tapered reamer. This is a carbide chucking reamer. It's called a chucking reamer because it has a straight cylindrical shank that you can grab in a chuck. It's a carbide reamer. You can tell, see, this right here is the cutting edge, and this part right here is rounded over. That's your cutting edge of this right here. This is a high-speed steel. This is actually the one that we're going to be using. You can see these blades, very popular today. Your flutes here are sharp all the way through. This is high-speed steel. Happens to be 6 flute. You can get them in different flute configurations and different numbers of flutes. But basically what the flute is there for is to carry the chips away from your cutting edge. Just like a tap. Those 2 flutes that are cutting the tap, is exactly what those are for too. You can also get them like this, which is a spiral flute reamer. These will work just like a drill bit, where the spiral pattern will carry the chips away and out. These ones you're going to have to clear manually. We're not going to have to worry about that on ours because our part is actually the same size as this, the same length as the flute, so we shouldn't have a problem with chip buildup. Now, it's also a reason why you can't use these. These are used to finish a hole, not to cut a hole. You can see there's no point on it, and there's no cutting edge on the front. You cannot cut a hole with a reamer. That's why you have to go one size lower on your drill bits. Anywhere. These are only really meant to remove a 32nd of an inch at most of a material, is what I would consider acceptable on a reamer. You don't want to do anything else. You'll either clog the chips, you'll wear it out real quick, or you break it. Especially with the carbide reamers, if you try to take a whole lot off on these, you'll tend to chip the carbide surface on them. These are another tapered reamer here. Like these are only tapered by also about a 2/1000 of an inch. This one's a high-speed steel tapered reamer, and then this one is a carbide tapered reamer. You can see the carbide inserts right at the front. This is a adjustable hand reamer. These collars will push these blades out to a certain point. Now, if you notice, it has a square area on the end. Anything with the square area, with the square shank on the end, including your taps, are meant to be driven by hand, by a tap wrench or an adjustable wrench. You can see how far these stick up and how much support they have. They're, they're relatively flimsy. If you were to try to use this at speed, you will break it. There's no question that you will break this. Anything with a square shank is meant to be driven by hand. Now, can you drive a tap by power? Yeah, you can. It's not really meant to be, but it is possible to do it. And that's your basic sets of reamers. You'll also have, there are taper pin reamers, which are a lot more tapered for your tapers, for your taper pins that your machine will use, and there's all different kinds. You can get them any size you want, over and under, whole sizes. Like we're going to use a 3/8 reamer, and we're going to be putting a 3/8 piece through it. Now, I would like to use 1/1000 over, a 376,000 reamer, but I don't have one. So what we're going to do is we're going to lap our screw to fit, and I'll show you how we do that. So let me set this up in the lathe, and we'll get to a little reaming demonstration. Alright, we're all set up to ream. Now when we ream, we want to turn our lathe really slow, so get this in back gear here. Alright, we're in back gear. Also, when you ream, you don't want to stop your bit in the middle of your cut. You want to advance smoothly. If you have to clear your chips, advance smoothly back out again. Clear your chips and go in smoothly again. You don't want to go into the middle of your part, stop, and then advance. Because that'll end up grinding. If for any reason this part's wobbling a little bit, it'll kind of chamfer one area. Also, it'll wear out your bits a lot faster, and you could have a chance of cracking a flute, especially if it's carbide. These like a lot of oil and a nice steady slow feed. Now we're only taking a 1/64 of an inch of material off the entire diameter, so we're not taking that much. A little bit more, we're almost to the other side. I can feel it. I can feel the pressure difference. And right there, we're through. And then smoothly back out without knocking the camera over. Now, you can see in here, there's all my chips packed into my flute. And that's exactly what they're meant to do. Alright, now let me get this out of the way and I'll show you our next step.